Hey there, science fans. Welcome to another exciting journey into the world of mathematics. Today we're diving into the fantastic world of functions in algebra. Functions are one of the most fundamental concepts in mathematics, and they play a crucial role in various fields, from computer science to engineering. Now don't let the word algebra scare you. It's not as complicated as it sounds. In fact, once you get the hang of it, you'll see how logical and straightforward it can be. Think of functions as special rules in math. These rules help us understand relationships between different quantities. They are like magical machines that take an input, do something to it, and give us an output. Let's break it down. Imagine you have a machine that follows a specific rule. You put something into the machine, and it transforms it into something else based on that rule. These rules take something and transform it into something else. For example, a function might take a number and double it. This means if you input a number, the function will output twice that number. Let's take a simple example. Imagine a function that doubles any number you put in. This is a very basic function, but it helps illustrate the concept. If you put in 2, it spits out 4. If you put in 5, it gives you 10. Pretty cool, right? This is the essence of what a function does. Functions can be more complex too. They can involve multiple steps or operations, but at their core, they always follow a specific rule to transform the input into the output. If you put in 5, it gives you 10. Functions can also be represented in different ways, such as through equations, graphs, or even tables. Each representation helps us understand the function from a different perspective. That's a function in action. It's like having a reliable machine that always gives you the correct output for any given input, as long as you follow the rule. It takes an input and gives you a specific output based on a set rule. Understanding functions is key to mastering algebra and many other areas of math. So get ready to explore more about functions and see how they make math both fun and functional. Think of a function like a vending machine. You put in money, your input, and select a snack. The machine uses its function, the snack selection process, to give you the snack you chose, your output. Each button in that vending machine represents a different rule, a different function. One button might give you chips, while another dispenses a candy bar. No matter what, you get a specific output based on the button, function you choose. That's how functions in math work too. They're like little machines that follow specific rules to give you a predictable output. Now let's get a little more specific. We're diving into the fascinating world of functions and relations. In the math world, a function is a special relationship between two sets of numbers. But what does that really mean? Let's break it down. Think of it like a dance where each partner has only one other person to dance with. Imagine a school dance where every student has a designated partner. The first set of numbers is called the domain, like the boys at the dance. These are the numbers that we start with, the ones that will be paired up. The second set is called the range, like the girls at the dance. These are the numbers that the domain numbers will be paired with. Each number in the domain can only be paired with one number in the range. This means that every boy at the dance has exactly one girl to dance with, and no one is left out. This one-to-one relationship is what makes a function special. It's a unique pairing where each element in the domain is matched with one and only one element in the range. It's like a perfect matchup where no one is left without a partner. In mathematical terms, this ensures that the function is well-defined and consistent. To understand this better, let's consider some real-life examples. Think about a vending machine. You press a button, the domain, and you get a specific snack, the range. Each button corresponds to one snack, just like each number in the domain corresponds to one number in the range. If you press the button for chips, you get chips. If you press the button for a soda, you get a soda. There's no confusion, and each button has a unique outcome. This is similar to how functions work in math. Each input, or domain, has a specific output, or range, and this relationship is clear and predictable. Understanding functions as relations helps us see the order and structure in mathematics. It shows us how different elements are connected and how they interact with each other. So next time you think about functions, remember the dance, the vending machine, and the unique pairings. These analogies can make the concept much easier to grasp and remember. Functions are all about relationships and connections, making math not just a subject, but a way to understand the world around us. Math can be abstract, but luckily we have graphs to help us visualize functions. A graph is like a map that shows us how a function behaves. We use two lines on our graph, the horizontal line, called the x-axis, and the vertical line, called the y-axis. We plot points on this graph where each point represents an input-output pair of our function. These points, when connected, form a line or a curve, giving us a visual representation of the function and its rule. Pretty neat, huh? Section 5. Independent versus dependent variables. Today, we are diving into the fascinating world of functions and their variables. Now let's talk about the stars of the function show, the variables. These are the building blocks that help us understand relationships in mathematics. In a function, we have two main characters, the independent variable and the dependent variable. These two work together to create a meaningful relationship. The independent variable is the one we get to choose. It's free to be any value we want. This freedom allows us to explore different scenarios and outcomes. Think of it like choosing your own adventure. Just as you decide the path in a story, you select the value of the independent variable. The dependent variable, on the other hand, depends on the independent variable. It's like the story's ending, which changes based on the choices you make. It's the outcome or result of the function's rule. The dependent variable is what we measure or observe in response to the independent variable. Let's go back to our doubling function. This is a simple yet powerful example to illustrate the relationship between these variables. If we write it as an equation, it would be y equals 2x. This means that for every value of x, y is twice that value. Here, x is our independent variable, and y is the dependent variable. The value of y is directly influenced by the value we assign to x. The value of y depends on whatever value we choose for x. This dependency is what makes the relationship between variables so interesting and useful in mathematics. Understanding this relationship helps us predict outcomes and make informed decisions. For instance, in real-life scenarios, we often use these variables to model situations. Scientists use independent and dependent variables to test hypotheses and analyze data. By manipulating the independent variable, they observe changes in the dependent variable. In business, analysts use these variables to forecast trends and make strategic decisions. The independent variable could be time, while the dependent variable could be sales figures. Even weather forecasters use these concepts to predict weather conditions. The independent variable might be atmospheric pressure, and the dependent variable could be the weather outcome. So whether you're in a classroom, a lab, or an office, understanding independent and dependent variables is crucial. It allows you to see the cause and effect relationships clearly. Remember, the independent variable is what you control, and the dependent variable is what you measure. This fundamental concept is the backbone of many scientific and mathematical analyses. Mastering this concept will not only help you in your studies but also in understanding the world around you. So, keep exploring, keep questioning, and keep learning. And that wraps up our discussion on independent and dependent variables. Stay curious and keep discovering the wonders of mathematics. Section 6. Steps to graphing a function. Ready to draw some graphs? Here's a step-by-step guide. First, choose your independent variable values. Pick a few values for your x input. Second, calculate the dependent variable. Plug each x value into your function's equation to get the corresponding y output values. Third, plot the points. Draw a dot on your graph where the x and y values meet for each pair. Finally, connect the dots. Use a ruler or draw a smooth line through your plotted points. Congratulations, you've just graphed a function. Section 7. The vertical line test. Now, how can we tell if a graph actually represents a function? We use the vertical line test. Imagine drawing straight vertical lines up and down your graph. If any of those lines hit your graphed line more than once, then it's not a function. Remember, each input in a function can have only one output. If a vertical line crosses the graph twice, it means one input has two outputs, breaking the function rule. Section 8. Why are functions important? You might be thinking, Bill, why should I care about functions? Well, my friend, functions are everywhere. They're not just some abstract math concept. We use functions to describe relationships in the real world, from predicting the weather to understanding how sound travels. Engineers use functions to design bridges, and economists use them to analyze markets. Functions help us make sense of the world around us, and that's pretty darn important. Section 9. Functions in real life. Let's say you're baking a cake. The recipe you're using is like a function. It tells you the exact relationship between the ingredients or input and the delicious cake you'll get as a result, the output. Or think about driving a car. The speed of your car changes depending on how much you press the gas pedal. That's a function too. The pressure on the pedal is your input, and the car's speed is the output. See, functions are everywhere. Section 10. Common misconceptions about functions. Now, let's clear up some confusion. Sometimes people think every equation is a function, but that's not true. Remember, a function has that special one-to-one relationship between inputs and outputs. Also, don't get thrown off by different ways of representing functions. We can describe them using equations, graphs, tables, or even just words. No matter how they're presented, the main idea remains the same. A function takes an input and gives you a single, predictable output based on its rule. Section 11. Conclusion. So there you have it, a whirlwind tour of functions. We've learned that functions are like special rules or machines that take inputs and transform them into outputs. We can graph these functions to visualize their behavior, and we can use the vertical line test to check if a graph represents a function. Remember, functions are everywhere, helping us understand and describe the world around us. So keep exploring, stay curious, and keep those mathematical minds buzzing.